Hello everyone, welcome to IGBits. We train, you learn. We shall continue our final revision about integration sums. Let's get started. We created a YouTube channel which does that our YouTube channel @IGBits. Feel free to subscribe the channel. We started uploading all our sessions in YouTube. You can utilize this opportunity and build your competency. All right. Yeah, thank you. Okay, let's try this problem. Integration of x cube by x plus 1 dx. This we can solve in two ways. If you look at a numerator and denominator, numerator is actually higher degree than the denominator. So the one thing would be like you divide it first and then make a like a simplified version. How do you do that? X cube divided by x plus 1. And you can start it factorizing. So if you can multiply with the x square into x cube plus x square into 1 x square. So subtract, done, minus x square. Next, maybe x times. So minus x times x is called minus x square, minus x into 1 plus x. Minus x. So again, apply subtraction. So signs will be opposite. This cut, this becomes like x. Now what you have to do? Plus 1, multiply with plus 1. 1 into x plus 1 into 1 1, subtract, done. So minus 1. How do you rewrite this one now? You have to rewrite, this is the remainder, right? And so x square minus x plus 1, we can rewrite this one, x square minus x plus 1 minus 1 by x plus 1, right? This goes here, minus 1 divided by x plus 1. This is how you have to write. Let's try with that now. So x square minus x plus 1 minus 1 by x plus 1 of dx. Now you see, it's easy, right? How do you do this? So you can apply individually. X square means x cube by 3 minus x means like x to the power 1 plus 1 by 1 plus 1. So this is x squared by 2. Integration of constant is x, right? And then you look at 1 by 1 plus x is like a 1 by t formula. So this would be the log t. Log x plus 1. You put one constant, right? Easy one. Right. What are the formulas that we used it here? Right? The formulas. Let's recall. Integration of x power n dx. If you look at this formula, x to the power of n plus 1 by n plus 1, right, plus constant. Integration of 1 by x dx. So what you do? Log of x plus c. Correct? No? This is what we did this one. Easy, right? You should be able to correlate. Get the answer. Good problem. Integration by parts. This is one thing that we have to remember. Let's say you have a two functions, u and then v, of function x. Then integration of u with dx can be written as u into integration of v dx minus integral of du by dx integration of v dx. I'm reiterating. Let's say this is a first function, right? This is a second function. So first function multiplied by integration of second function minus integral of differentiation of first function integration of second function dx of dx is what basically integration by parts, right? So but how do you choose, which one is the first function, which one would be the second function? If you look at the given problem statement at any given point of time, one of the function given is not directly integrable. Think about like a sine inverse x, cos inverse x, tan inverse x. Whatever is not directly integrable, you can always take it that as a first function. With that you can use it as a differentiation concept, right? As a u. Then you will be able to solve the problem. Are you clear? Yeah, this is I think one thing that we need to understand. This is very easy. See, integration of u v dx is nothing but u multiplied by integration of v dx minus integral of differentiation of first function and integration of v dx second function, for which you have integral, one more integration you are doing. That's how actually uv in the integration. We will see one or two examples, then you can get it the a feel of how you can solve the problem. I'm sure I think some of you already solved it, right? It's not something new that we are studying today. Clear? Let's try this problem using integration by parts UV method. So one function which is not an integrable should be considered as like a second function. Something you can do integration easily can be considered as a UV. So our case, this would be function 1, this would be 2. Think about that way. How do you solve this problem? Integration of UV, just we discussed integration of UV. How do you do that? U integration of V dx minus, right, integration of du by dx and integration of V dx whole dx, correct? So let's start over now. This would be u. So this would be u, this would be v, and then you apply this fundamental. So the first one I leave the log x common because I'm not going to touch now, and then I will integrate to x dx. Okay, then minus I would integration du by dx, right? Log x. D of log x is how much? I'll put like a d by dx of log x. Okay, then integration of x dx, then whole dx. This is how I think I'm replacing. Now you can make it easy. Log x, integration of x, how much? X squared by 2. We know the formula, right? Integral power minus log x, probably 1 by x. Agree? So integration, this would be 1 by x, and then integration of x dx is equal to x squared by 2 and dx. Now let's see. This would be remain same. So I will make it x squared by 2 log x minus here x times x1, right? So order x by 2 dx. Basically is 1 by 2 into x. Then you can further simplify now. X by 2 log x minus 1 by 2. Integration of x is nothing but x squared by 2 plus c. So how do you rewrite it? x square by 2 log x minus x to the power of x square by 4 plus c. This would be your answer. Clear? So this formula you have to remember and then practice. Okay, let's try this one. Integration of x plus sin x by 1 plus cos x dx. It sounds to me f of x by f dash x dx. But I don't see like we have something like this, right? F dash x by f of x dx probably is a direct, but this other way around. We can't solve this problem. Then how are you going to do this? So let's convert this from 1 plus cos 2x. We know that, right? Cos x is nothing but cos 2 of x by 2. Cos 2 theta. How do you say? 2 cos square x by 2 minus 1. So 1 plus cos x is nothing but 2 cos square x by 2. Can we write that one? So now x sin x, x by sin x means like 1 plus cos x, right? 1 plus cos x. How do you write it? 2 cos square x by 2. Agree? So that means 1 x by 1 plus cos x plus sin x by 1 plus cos x. That is how I can write, no? X by 1 plus cos x plus sin x by 1 plus cos x, right? I can separate that way. So this whole part is now 2 cos square x by 2. Right? 1 by 2 into x secant square x by 2. That's one thing that I can write it. And second portion would be this one, sin x by 1 plus cos x. Sin x I can write like sin x as a 2 sin theta cos theta. 2 sin x by 2 cos x by 2. Agree? Then what happened here? 2 sin x by 2 cos x by 2 divided by 2 cos square x by 2 because of I'm replacing this. So let's say 2 done, this one portion is done. Then 1 by 2 out, integration of x secant square x by 2 plus how much this will be? Integration of tan x by 2 dx. So to solve this problem now, this becomes like a UV. X secant square x by 2 would be the UV formula. We have to do by parts. Integration by parts is what we have to use here. So what is the UV formula that we talk about? Integration of UV dx. What you're saying? Choose this is first function, this is second function, and then you're saying like u integration of v dx minus integral of du by dx integration of v dx, the whole part dx. Correct? This formula will apply here. Correct? No? Once you understand the formula, that what is a big deal? You should be able to do that. So let's keep one thing. Which one you choose UV here? Which one can be integrated easily for comparison? So secant square can be integrated. Integration of secant square. Then I leave the x as is. That's why I can simplify further in this. So my UV would be x remains x. Integration of v dx. Integration of secant square x by 2 would be tan x by 2 by 1 by 2, right? Next one minus integration of du by dx. U means like x. Differentiation of x is nothing but 1 only. So integration of then integral of v dx. Integral of v dx is how much? Just now we did this one, right? Tan x by 2 by 1 by 2. So we will say this one tan x by 2 by 1 by 2 1 by 2, right, dx plus integration of tan x by 2 dx. So this 1 by 2 would be for this portion, right? That means like I can apply 1 by 2 here. So 1 by 2, 1 by 2 gone, 1 by 2, 1 by 2 gone. Right, then integration of tan x by 2. This is plus tan x by 2. These two things will cuts out. 1 by 2, 1 by cut out. So what is remaining now? The remaining is x tan x by 2 plus c. This is an answer. So the answer would be this one, answer D. This you have to be compare correctly, to solve the problem. Next problem, integration of dx by x into x to the power 4 plus 1. X times x to the power 4 plus 1. Think about it, how to do this. This is a kind of like a partial fraction method would be easy for solving this one. Let me try integration now. In the numerator I have only one, correct? 1 dx. So what I would do, I can rewrite this one x plus 1 and x to the power 4 plus 1 minus x to the power 4 is nothing but 1 only, right? There is no real change, divided by x into x to the power 4 plus 1 dx, correct? Now I can now split it. Integration of x to the power 4 plus 1 divided by x into x to the power 4 plus 1. Agree? Right. Minus, how do you write this one? X to the power 4 by x into x to the power 4 plus 1 dx. Now it looks easy. These two cut. So we have only one left over, 1 by x. Integration of 1 by x dx. Do the same thing here. X to the power 4. If I cut short, integration of this one x cube divided by x to the power 4 plus 1 dx. Now you see, this is a straight log x, no doubt in this. Minus, if you look at here, if let's say like t is equal to x to the power 4 plus 1, t equal to x to the power 4 plus 1. What about dt? dt equal to 4x to the power of 3 dx. So x cube dx would be dt by 4, correct? So can you rewrite now? So how do you replace this one now? It is nothing but integration of 1 by 4 and 1 by t dt. It is nothing but log t. So log x minus 1 by 4 log t. T means how much? T means this overall. You have to replace x to the 4 plus 1 plus c. Correct? This is an answer. Easy. Thanks for watching. Please like, share, subscribe, click on bell icon and leave the comments. We reached the end of session. Thanks for all who are actually joined today's class. I hope this class is useful. Try to spend some time, quality time in your preparation. Okay. Stay tuned to next session. See you tomorrow, guys. Okay. Have a good day.